We will start the webinar, and I will be doing a little introduction first. So, first of all, well, Arcade 5 today is pleased to present this webinar in association with the CTBUH. And this will be, the topic will be the impact and complexity of the carbon footprint within the future of our cities. So, some more introductions. First of all, about Arcade 5 Group, for those who would not know us already. Well, we are one of the largest private consultancy firm in the Asia Pacific, with core services in architecture and master planning, building and infrastructure, engineering and industrial and process engineering, as well as project and construction management. Our expertise covers key construction sectors such as building and real estate, industry and manufacturing, and energy and infrastructure. Arcade 5 Group has been a country representative of the CTBUH, and this for several years already, and this for Mongolia, Myanmar, and Cambodia. So you may also want to know about CTBUH. So CTBUH means for Council on Tall Building and Urban Habitat. The CTBUH is an organizational member network which regroup today over 2 million individuals working in over 10,000 offices, and this over 100 countries around the world. It includes owners, developers, financials, architects, engineers, urban planners, etc. And it's one of the world's leading non-profit organizations which explore how increased urban density and vertical growth can support more sustainable and healthy cities, which is one of the topics of today. So also the CTBUH is best known to the public as the arbiter of tall building height and the global authority that award titles such as the world's tallest building. So the CTBUH also provide a platform for both information share and business networking for all companies and professionals. And finally, we were, I would say, glad that this will soon come back to have annual conferences around the globe organized by the CTBUH. So therefore, I also encourage everyone to join this fantastic organization doing a great job on the tall buildings and urban habitat. So today we are pleased to welcome with us our distinguished guests. First of all, I will introduce Eleni. Eleni, who is, sorry if I scratch your name, Eleni Polikroniadou, who is the co-founder and commercial director of Curtailing Group, Curtailing company, and who is joining us from London. She will be introducing the EDGE certification and showing some projects around the world who received this green label. She will be, of course, introducing EDGE, but first of all, maybe a few words about Curtailing. Curtailing is an environmental certification body which was founded to verify the impact of the building environment around the world. Curtailing acts as a global certification partner of IFC EDGE Green Building Program, and this since 2015, and alongside with SGS. This for transforming the built environment and creating pathways in over 60 countries. So before Eleni talks more about EDGE, just for information, for those again who would not be familiar with, EDGE is known as Excellence in Design for Great Efficiencies. It's a green building certification created by the IFC, International Finance Corporation, which is a member of the World Bank Group. And this, for the past 10 years, Arcade 5 as well has been promoting in the region with an MOU signed with the IFC in order to promote the H certification. So another of our guests today is Tuan Chan, who is an archetype group based in Vietnam, green design manager, so in charge of all the green aspect of our design, who is joining today, and Tumen Bartaku, who is our managing director from Archetype in Mongolia, who will be presenting a project about affordable housing. Finally, myself, I'm the director of architecture for Archetype Group, and I will be presenting a theme based on mass timber usage. So after this long introduction, so let's jump into the presentation themselves. And I will let the floor, the microphone to Tuan, who will be having an introduction on carbon topic and edge.
Okay. Hello, and thank you, Mark, for the introduction. And thank you, CTBUH, for having me today. My name is Tuan Trang. I'm working as a green design manager for Archetype Vietnam. And I'm in charge of supporting design team to implement green design for our project, and working as a green consultant for green building certification. And the topic for the webinar today is about carbon emission. And most people are already familiar with the carbon footprint concept. So carbon footprint indicating human activity related greenhouse gas emission would contribute to global warming. And can you change the slide, please? This world carbon emission map represents each country's development, but also its environmental impact. The carbon footprint emission would cause global warming is a global issue, and it is surely impossible to reduce the carbon emission without actions from all countries and the mutual collaboration from everyone. So nowadays, Asian countries become driving force for the world economy, and with high population and economic growth, the carbon emission of Asia account for more than 50% of world carbon emission. And of course, China is the country that releases the most carbon emission in the world, and Asia. Following China, the developed countries like India, Japan, and South Korea. Other countries like Vietnam, Malaysia, Indonesia, Mongolia, Laos, Cambodia, etc., release less emission in compared to the developing countries, but actually they play important part of the global carbon emission reduction, and especially they are the most countries that could be affected much from the global warming issues. So where we want to go now? There is a projection of the future of global mean temperature. And you might know country leaders just joined the UN Climate Change Conference 2026 this year to update each country action toward carbon emission reduction, and reconfirm their commitments to the carbon emission reduction target in order to limit the global temperature rise to stay below 2 Celsius above the pre-industry level by 2100. The green line you can see on the chart. And to meet the ambitious target, country must reduce carbon emission by 45% by 2030 and zero carbon emission by 2050. However, before the COP26, the World Energy Outlook Report 2021 showed that even under the state policy scenario, the blue line, if this were implemented in full and on time, we still meet the goal of the Paris Agreement. The world would be headed for 2.1 Celsius of warming by the end of the century, instead of stay below 2 Celsius as our target. So the COP26 actually the world's effort to bring back the target back on track. And the most important is the green measures should be affordable, energy efficient, clean energy for building and infrastructure. So today is about the high-rise buildings, and yes, building play a big role in the ambitious target. And nowadays, buildings generate 40% of the annual carbon emission. And the large proportion of such emission is from the energy used for building operation, 28% you can see, and we call that a operational energy, and 11% from the energy we call embodied energy, with the energy used for during the extracting the raw material until it becomes the component in the buildings. So let me explain a bit about the operational energy and embodied energy in buildings. So during a life cycle of a building, around 90% of its energy consumption is for operational activities, and only 10% for embodied energy. So energy used for cooling, for heating, within the big part of the operational energy. And for the embodied energy, the building slab, the roof is a big part of the embodied energy. So this is what we should looking at when we try to optimize the design, and even we should have a good communication with all project stakeholders and even educate clients on the long-term target instead of short-term goals. So since operational energy account for 90% of the total energy consumption of the building's lifetime, the target of carbon emission reduction in the building is to reduce the operational carbon emission intensity. The baseline in the operational carbon emission of a typical office building in some Southeast Asia country, you see in the chart here, Vietnam emits 8.3 kilogram of carbon emission per square meter per year, actually. And it is on the top. That means Vietnam is the least energy efficiency, while Singapore only 1/3, 2.7. So Singapore actually doing a good job in the for other country if we compare to other country within the region and even the world. Okay, so when it comes to the tool that help the design team to achieve the carbon emission, we would like to introduce Edge Green Building Rating System, with I think an advanced and innovative tool to help the project team in designing of energy efficient buildings achieve carbon emission reduction target. For some people who haven't heard about Edge yet, a quick introduction of Edge is establish a baseline and help design team to reach a target of reduction of 20% in every three categories: energy, water, and material. So Edge had 3 award levels. The first level is a certified level for the project meet the 20% reduction. A higher level is Edge Advanced for a project achieve 40% or more on-site energy saving. And the highest level is Edge Zero Carbon for project to achieve the Edge Advanced with 100% of renewable energy on-site or off-site, or with the carbon offset, emission offset. To continue, I would like to introduce Ms. Alani. She's already introduced. She's the co-founder and commercial director of CTBUH, and she will present how Edge can support on zero carbon and some case study around the world.
Thank you very much. So I think Edge has been a really valuable tool, and it's really been great to see how Edge has been implemented across the region. We, as Tran said, there's such an urgent need to reduce carbon emissions, and buildings play such an important role. And so one of the things is finding the right tools to really reduce that, both operational and embodied carbon. But the other thing as well is to find the tool to do this at scale. So we know we have this net zero target by 2050, and we know it's highly, highly ambitious. And if we take the approach of thinking about an individual building at a time, we're never going to make it, because simply the math doesn't make sense. If you think about how much time and effort it takes to green just one building, and then think about every building we have on this planet, it just doesn't add up. And so Edge not only gives you a pathway for zero carbon, but it also gives you a pathway to do this and implementing it at scale. And that's really what I'm going to be talking about today. So if we shift on to the next slide, I'll give you a little introduction in terms of our methodology that we have developed through Centali SGS to help companies be able to reach zero carbon at scale for their portfolio of buildings. So when we're talking about portfolios of buildings, what we're doing with clients is thinking about every building they have, whether that's a new pipeline, the new developments coming up, or their existing assets. Edge can be used for existing and new buildings, and can be used to map out the road to net zero for both sets. Now, we take a methodology which has been tried and tested around the world, and essentially we start through this evaluation phase, then moving into planning, implementing, and scaling. And you'll see at the bottom, we have this element of validation, which sits at the bottom. It's not really a step, but rather something that customers do along the way to really validate their progress, because zero carbon isn't going to happen overnight. We're not going to wake up tomorrow and have the entire building stock around the world be zero carbon. It's a journey, and we have to work on that through improvements and through progress and validation to be able to get to this net zero goal by 2050. Let's take a deeper dive and see how it actually works in practice. So if we shift into the evaluation phase, what does evaluation mean? If you shift onto the next slide. Evaluation is really understanding where you are today. So just like any other industry and practice, you can't make decisions and improve without knowing and having the data about where your buildings are today. And that's really where the Edge tool comes in handy with the free Edge app, which allows you to really evaluate your existing buildings or your new designs of buildings compared to a local base case, and really build out and understand where they compare to local benchmarks. Now, there are local base cases for every single country around the world, which is an incredible tool. And for anyone who's been in the green building industry, quite a rare and wonderful thing to have access to such data. And these base cases are built with local building regulations, standard industry practices in those particular regions, climatic data, typical utility costs, etc., to allow you to understand where does your building stand compared to the industry standard in that particular region. So this is a stage where you set your benchmarks and you understand where you are, so that you can also start to lay out the roadmap for where you need to get to really get to those zero carbon levels that we talked about. So we then move on to the second stage, which is the planning. And that's really the, my co-founder likes to call it the optioneering. Still not convinced that's a word. Stage, but that's really understanding what are the different options that you have, and what combination of measures could you implement to get to zero carbon. Now, Edge, in addition to having this local base case, also has a list of different efficiency measures of everything you could do in your building to make it more efficient and to reduce the carbon of that particular building. So you literally have all your options. And what you can do is use the application to see what combinations have the best output, which is really the best return on investment for you, the lowest incremental cost with the highest savings possible. You can identify different combinations. You can also identify the different steps you need to take. So for example, particularly if you're looking at larger portfolios, what can you do in year 1? What can you do in year 2? What can you do in year 3 to really space out and take a more step-by-step approach to get to the net zero carbon goal? So identifying really your combinations, your steps, and the Edge app does this initial costing for you as well by giving you that incremental cost and return on investment data. So you have all the data at your fingertips, and clients around the world are using that in this stage to look at their portfolios of buildings to really evaluate what the different options are and start building the business case for shifting to zero carbon, because we know we need to get to zero carbon, but of course there's always that element of building the business case and getting that internal buy-in to make it happen. Now, once you have a good sense of what you want to do, you then can take all that information to a cost consultant, get that final project outlined, really figure out what materials or what specific technology you will need to be able to implement. And again, lay it out over time. You might have the easy wins in the beginning, the ones that might have the lowest cost and the shortest time to implement, and build up to the more expensive investments to move towards zero carbon, such as ultimately investing in renewable energy, which is likely needed as we shift to zero carbon. But this is really the implementation phase, and also really finding those efficiencies of scale. And that's another element as to why implementing portfolio approaches makes sense, is because when you're able to do this across a portfolio of multiple buildings, you're able to realize efficiency savings, simply some things as simple as bulk discounts and being able to implement something across hundreds of buildings instead of one building at a time. So really looking at those time savings and implementing it in a way that makes sense. So you have your plan in place, you've started implementing it. So then you start to shift your portfolio to zero carbon. And as I mentioned, if we shift onto the next slide, it doesn't happen overnight. And particularly as we're thinking about these greater schemes, when we're thinking about a company's entire building stock or entire pipeline of buildings, it isn't going to happen overnight. But being able to validate that progress and set those targets and slowly start to see how those improvements are being made over time gets us to this end goal of having zero carbon by 2050 for new and existing buildings. And I think that's so important, because in a lot of narratives, we focus so much on new buildings. And of course, it's a lot easier sometimes to focus on a design when you're starting from a blank slate. But when we're talking about global emissions and we're talking about the climate crisis, we have to remember that it's new and existing buildings, that we can't just ignore everything that's already been built or everything that's being built to date. Because if we think about all the construction happening now, if it's all not green now, it will have to be retrofit to meet this 2050 goal. So there's a lot going on in the space, but the Edge app and the Edge process really make it as streamlined and simple as possible to help companies really move through this process and think about building the pathway towards zero carbon, setting very tangible, quantifiable goals, and really validating the progress along the way. Now, this all sounds great in theory. The good news is it's not just theory, but actually has been done in practice by different companies around the world. And we've seen so many moving recently, particularly given the large climate negotiations we had earlier this year and the general momentum within the industry. So I'll give you a few examples from around the world. First of all, the first zero carbon portfolio, which is in the Philippines, with NEO offices. So NEO had 7 existing offices, all entirely different, and they wanted to move towards zero carbon. They had international tenants who were interested in having certified green buildings. They had their own sustainability commitments. And so what they did is that they designed they did a retrofit design using the Edge app to identify how to get the building to zero carbon, and were able to certify the retrofit design and now have 2 years to actually implement it. And then whilst they're in this implementation phase, they're using offsetting and renewable energy to account for the actual operational energy being used right now. And so there's a very interesting story here in terms of how do you use the tool and how do you use the resources that you have to actually, again, lay out that pathway and know that it's now 2021. So by 2023, their buildings will be retrofit. They will be highly efficient and completely zero carbon. And this was an interesting one in the sense that they were all very, very different buildings. But again, taking that sort of high level approach and saying, okay, well, they all need to be zero carbon. So how can I aggregate them together and do this at scale became very, very effective. If we shift on to another example across the world in Europe, we had ProCredit Bulgaria. ProCredit is an international SME bank. and they did a zero carbon, their headquarters as zero carbon last year. And that was interesting in the sense that, again, they were taking that approach of evaluating and using the tool to set out validation milestones. So they actually went through the entire EDGE process where they first got EDGE certification, and then they went back and made additional improvements to improve that efficiency percentage. They then went back and got EDGE advanced, and then from there moved to zero carbon. So again, thinking about the pathway to zero carbon, it's really about setting those milestones, those quantifiable metrics, and using the validation to get to the end goal. And one of the things that ProCredit's also doing is actually using this as an example and a way to inspire and support their clients. So really working through the actual financial means as well, to stimulate more transition to zero carbon as well, and leading by example. One final case study from my side, and I'll pass the virtual microphone back to the team. So when we talk about portfolios, they can be small, like 7 buildings, they can be big, such as 215 buildings over here with Little Greece. So Little Greece hasn't gone to zero carbon yet. They are in the middle of their journey of setting out that pathway to zero carbon. But what they have been doing is using the EDGE tool to really think about the quantification of impact, to really set out again that strategy, and to really move towards how are they going to get to zero carbon. This one starts to feel a little bit more of the problem where we have a lot of older buildings. So Little was dealing with some buildings of sort of 15 and 20 years, and I'm personally sitting in London, and we know we have buildings here that are 100 and 200 years old. So the challenge of actually getting these to zero carbon is massive and should not be underestimated. And so that pathway and that setting out of a plan and really thinking through the options and how to do it in a way that makes sense for the business as well as for the environment and reducing carbon is really, really important. And so with Little, they were able to access international financing by doing this first stage of the approach and figuring out how to implement green buildings at scale to be able to eventually get to zero carbon. Because I think that's the key thing, is how do you continue this journey and how do you make sure that that end goal is actually happening and is not just a vague commitment, but really has a plan in place about how you're going to get there. Now, I hope these examples have served as inspiration. There's many more happening around the world, but you can see that there's many different ways to get to zero carbon, and you have incredible resources available to you from the free side in terms of the tool, but also through expertise from people like Archetype who can really support you on your way, because you don't have to start from scratch. Many people are doing it. So I hope this serves as a great example as to how you can also do it.
Well, thank you, Eleni. Thank you. So we will jump back to Tuan, who will also present some case study but in Vietnam after Europe. So Tuan, please.
Okay, thank you. So I would like to showcase some of our project. This is the first our EDGE certified project in Vietnam back in 2017. And you know, the Ho Chi Minh City, the busy with strong economic growth in Vietnam, and the number of the high-rise apartment is blooming since the very high demand of housing and the high population. So this project is a group of mixed-use residential building, include about 20-story high-end apartment, and the project actually achieved with 22% of energy less, 21 and water less, and 37 embodied energy less than the baseline. I mean the industrial practice for the similar type of the building. And this snapshot of the EDGE certificate show some of the green measure we have been we implement in our project, and I would like to explain more on the next slide. So for embodied energy, I would like to emphasize that the significance of the embodied energy part saving when we're looking at the comparison, the list of the floor slabs. The baseline is the in-situ concrete slab, and there are more material type that use like carbon in production and transportation. And also for the local material, you see the five clay brick is a typical and reliable material used in Vietnam for years, but it was replaced with concrete block with lower embodied energy and potential for recyclability and reusability. And for most 50% of embodied energy of a building is from floor slab and the roof. Especially for a high-rise building. So instead of using traditional in-situ concrete, we can have other construction concrete slab to reduce the embodied energy and the cost. For example, with the GGBS to add into the concrete, we can reduce the use of cement in the concrete. So we can reduce up to 70% of embodied energy. Or hollow slab can reduce up to 30%, or maybe also better for noise insulation in the slab. Thinner slabs such as concrete on the metal desking or post tension slab can reduce up to 40% of embodied energy consumption. For the operational energy, which is in the next slide, you can look at the strategy. So we reduced the cooling energy load with the high performance window, insulated roof, and efficient HVAC system, which is a very typical for on the building that we design for our projects. And as the result, for the next slide, the total saving of the project is to reduce 3,600 megawatt per year for embodied energy, and 144 megawatt of electricity per year, which is equivalent for 81 ton of carbon emission per year, which is very, significant. So the edge actually, the nice thing is the edge can show instantly the saving, which are superior to many green rating systems. It can break down into different energies used like cooling, heating, lighting, or for material, it can break down into slab, windows, roof, and you can see significant reduction of the cooling, reduction of the embodied energy from the slab. So from the app, yeah. The next slide, I would like to showcase another project in Cambodia. So this actually is not related to LEED, so sorry for Edge, but this project actually a recent design office building in Cambodia. The administrative building for Cambodia National Assembly attention, and the project will be constructed in the early of 2022 next year, and to be completed by the end of 2023. This project, we haven't followed any green certification system, but actually we implemented the many green design strategy because we want the project as the model for sustainable institutional building in Cambodia. So the first thing we try to implement the natural ventilation strategy for the building, and you can see this is the not very high-rise building. It's about 18-story height. If feasible, the natural ventilation is a good solution for reduce a lot of energy used for air conditioners. You know that cooling is the most part of the energy consumption. So actually, it's quite difficult to achieve the thermal comfort requirement in such a very hot and humid climate, like in Cambodia, in Vietnam, and South Asia. So we proposed the natural ventilation strategy for the central hall of the 12th floor. The central hall acts as the thermal transitional space. So people from the outside of the building they will have a little time to adjust their thermal sensation, and they will feel more comfortable before they get into the air-conditioned rooms. So to do so, we utilize the local prevailing wind direction, which is from the north-south direction. You can see the windrows here. And we take that advantage to create an airflow pack, thanks to the pressure differential between the opening. In more detail for this slide, you can see the actual implementation of the combination of the stack and cross ventilation. And we also add the transfer duct above the office ceiling. And you can see the small on the bottom right. It is used to provide the outlet for the wind flow and to avoid the noise crossover between the hall and the office space. And the other thing for the energy saving is the design strategy to optimize for the wood tail lighting and also reduce the energy used for lighting, which is the second large part of the energy used for any office building. So we use the modeling, we can identify the amount of solar radiation incident on the glazed surface, and we propose the solar adaptive shading control device so that we can maximize the natural lighting, and also we can block the sunlight and protect the glare. Yeah, and you can see in this a typical plan, we can identify the location for different type of the shading device, so we can save the cost for the project as well. The last thing, which is not related to the energy efficiency, but the visual comfort. For this case, we deal with the glare problem because this is the office building. So what we did is we used the computer modeling to calculate the daylight glare probability based on the different type of the glazing. In this slide, you can see we did the modeling for two different spaces, office room and a meeting room for 3 different times of the dates, and for 3 different type of the glazing. We use the different value for VLT, mean visible light transmittance, and you can see the DGP less than 0.35 is recommended, and the DGP is more than 0.45 is intolerable glare or unacceptable. And with the modeling, we can identify the right glazing type for the building. So based on such modeling, we can come up with the glazing construction type that can take the energy saving into account and also tackle on the glare issues. The glazing is a high performing the IGU type with the low E coating on the second layer of the first glazing pan for solar control. You can see we have a more green design feature from the project. Well, actually, this is the last slide for this case study, and I would like to transfer to Mr. Tuman. He will discuss more about the project in Mongolia. Thank you very much.
Thank you very much, Tuan, for these examples. Very interesting. Now, I think it's the time for Tuman to introduce its study case in Ulaanbaatar. Is it? Yes, correct.
Yes, that is correct. Okay.
Then you can say your screen.
I'll be sharing the screen. Okay, I hope everybody can see my screen. Okay, so thank you for having me. I'm Tuman, I'm Managing Director of Mongolia. So today I'm going to be introducing the project that we have done in Ulaanbaatar in Mongolia. It's called Affordable Housing. So first of all, in order to show the project we have implemented by Architect Mongolia, I would like to introduce the background and the story behind this, the project that we've taken part of. So I'm just going to go a little bit about this history, the current situation about Mongolia, because I guess from the history we know Mongolia, but we do not know what is the situation today in 2021. So Mongolia is about 1.6 million square kilometers with a population of only 3.2 million people, which means it's one of the 19th biggest countries with the with a few people living on a big land. The arable land is estimated to constitute only 0.8% of this vast country. It's located between China and Russia. It's a landlocked. So I'm going to be presenting because the project is in Ulaanbaatar, the capital city, where I'm going to be talking about Ulaanbaatar. So Ulaanbaatar is one of the coldest capital cities in the world. During the summer, it is 25 plus 25. During the winter, the coldest winter seasons, it's minus 35, which means the differences between temperatures is quite high. The city was founded in 1939 and it moved 28 times and then eventually settled right in this location more than 250 years ago. However, when choosing the location of the city, during that time, the nomadic people usually located near the mountain areas so we can block the wind during the winter. So unfortunately, I would say it is not the best location for the capital city to be located. So we got 7 districts over here, as shown in the picture. And then you can see the map on the left side, left bottom corner. You can see that the Ulaanbaatar is surrounded with the mountains from the north, and we have a mountain to the south with a river in the south. So the only way the Ulaanbaatar can expand is to the west and east. So you can see on the picture over here. So in the Ulaanbaatar, we have a population of 1.4 million people, which out of them, 60% of people are living in a low density with the poor infrastructure, which means 840,000 people living in the ger areas, which is, I'll show you, introduce you later, what is the ger area. These areas have lack of basic urban services that affects the quality of the life. You can see on the picture the current situation of the Mongolian Ulaanbaatar city. Moving to the next slide. So what is a ger area? Ger is a traditional yurt that we used to be using for 1,000 years for Mongolia. And when I know I'm going to be a little bit historical, but the USSR failed, and with Mongolia in 1991, we have moved to democracy. People were freely moved in whatever place they want to live. So without any management, people moved to Ulaanbaatar city to improve their life and settle down wherever they want. Eventually, this leads to a very unmanaged district with full of residential areas without any basic infrastructures. So because of, as I said, mismanagement, we have difficulties with the pollution problems. It's a very serious problem that we're facing here today in Mongolia. More than 10 years ago, I remember the city wasn't like this. The air pollution is, although it's been improving for the last 2 years, it is one of the worst in the world during the winter times because people use coal to get basic heating. So you can see on the picture that the situation during the cold winter seasons, how the conditions of people are living. So this is the first problem that we're facing in Ulaanbaatar. Secondly, we have a poor sanitation from almost exclusive reliance on the open pit, which is a toilet that only use a dug pit without any basic management. Then we have third, poor solid waste collection. This is again comes to mismanagement. Fourth, limited access to the potable water. We call them water kiosks. So within a certain amount of area, we have a couple of kiosks for the people to get the water. And with high people living whatever place they want, it also affects in the fifth, which is the traffic congestions. There are no roads that urban plan that should be implementing. And the sixth is a critical lack of public space. Kindergarten, schools, commercial areas, parks, and this is also affects the local people, the quality of the life. So on the map, recently, for the past 10 years, a government has been trying to improve the quality of the life with the help of Asian Development Bank. There are several projects that are supporting and trying to improve people's lives in Ulaanbaatar city. On the left side of this map, you can see how it is defined. The majority of the people, please note that actually Ulaanbaatar during the originally only planned for 500,000 people. It's 500,000 people. Today, it's more than doubled. It's almost tripled. You can see the original design right down the center of the Ulaanbaatar city. Then we have an industrial site, which is shown in the blue. And then we have a ghetto areas where it's shown it is occupied and settled in every valley that is possible up to the north. So this is the area which is 60% of the population is living over here without any very poor infrastructure. So this is the problem that we need to be fixing. So one of the resolutions is the government supplies with the basic infrastructure so people can move into the residential area. So if we are currently we have 33 people living per hectare. This is not an average estimated. By swapping the land for the residential area, people can move into the house to residential blocks with the 270 people per hectare. So this is one of the ideas, and this is what our project has been all about. Our project is to inspire, to be an example for the rest of the construction companies, businessmen, investors. So the area with the ghetto areas can improve and have a better quality life for the whole city as well. So the project land is right here on the left. I'm showing in red. It's 4 households, 4 families live there. They are about to swap the 4 apartments that we have planned. So we got 4 blocks we call A and B, and A and B. A is similar with the B, and B is similar, which is connected with that. Totally, the land area is 2,900 square meters. with the 20 apartments, which means 4 households, the landowner is going to be moving in, and the rest 16 apartments could be sold and eventually get the benefit, the construction companies doing it. Total GFA of the blocks is at 1,920 square meters, with the green area 774 square meters. So one of the basic ideas that affordable housing is, we're going back to the history where during the socialist times, where affordable housing were done by the government and regulated by the government. It's easy to build, especially it's a precast concrete. It's easy to build, especially for the countries which is during the winter time, the construction stops when you're using C2. This precast concrete the benefits is, because it is manufactured inside, the quality can be controlled and very easy to assemble. It can be assembled during the winter. Also, it can be mass produced. So the idea of this project, we're going back to the original idea, because this is affordable housing. This is should be for everyone to live. So this is the layout that we have done. On the left side, this is the first floor. One of the things that we have done is not only we are providing a basic accommodation for the people, but we're also trying to support the people to have the works and the workshops, small businesses, that they don't have to travel all down to the downtown to get a job. So the first floor layout is only garage to the north, and then we have to the south where small workshops are here. So the local people can do and work over here to have them art shops, workshops, and supporting themselves. The second thing we have done is to have a 2 access for each blocks. This is A block, this is B block, 2 access, so that eventually, when in the future this whole area is going to be hopefully filled with this kind of a simple design, they can just combine, take block A, combine with the A depending on the site, and then B combined with B, and then A. So it can be easily organized like a Lego game. That is why we have 2 access, so that people can go freely within the blocks to have the whole district to be similar. And the other thing, this is the second floor. Very simple design. We have A block is a 1-bedroom with the living room, with the storage and a kitchen over here, and WC. 2 household per floor. B slightly bigger with the 2 bedrooms, living room, toilet, and a kitchen. This affordable housing should not be it should be a low rise, as you can see on the elevation, because we don't have too much density in the area. So A block is a 4 floors, and the B block is a 3 floors. Access to the workshop and garage is directly from the outside. Currently, this project was due to end of this year. It is already started. Construction has already been started. However, due to the COVID pandemic, we have problems with materials, transportation, workforce. So the construction is still ongoing. It should be able to finish in the first season of 2022. In conclusion, I hope the results will show in the future that this can be set as an example to future investors to help out gated areas to improve the quality of the life. This is my last slide, and I'm going to be passing my microphone back to Mark. Thank you very much for having me. Mark, microphone. Mark, microphone.
It's funny, I pressed once already. Anyway, thank you very much, Tumen. Let's hope that this type of initiatives will help Ulaanbaatar to reduce the production of the famous pollution is present every winter, especially in Ulaanbaatar. Tough times. Huh? Okay, so now from my side, I'm glad today to share with you a presentation on a topic which is mass timber in the conservation of carbon footprint and its reduction. So first of all, I would like to put back into context what we call mass timber. Mass timber or massive timber is a set of structural building materials that are assembled in smaller wood sections. These into large and multi-layered panels, beams and columns, which are used to build multi-story buildings, either for commercial, housing, or institutional use so far. It was, for now, widely used in Europe, Canada, Japan, Australia, and New Zealand already. Today in the US, the number of mass timber building completed or in design has increased from approximately 30 buildings in 2013 to over 1,000 in 2020. And in 2021, the International Building Code, the IBC, has allowed mass timber to be used for building up to 18 stories. So mass timber can be used as well for full building structures or in hybrid designs with light frame wood or steel and light gauge metal, as well as concrete systems. But before we talk about a more technical aspect and study case on mass timber, I wanted before to present a wider problem, a macro issue. Indeed, same as the tip of an iceberg, there are deeper roots in just using mass timber in construction nowadays. Indeed, you would say why cutting trees would be beneficial to the environment, as we need to do so to use mass timber technology. How is it beneficial to the environment? How can we relate that to the global climate warming? Well, a bit of definition first. Well, as you may all know already, forests are defined as acting both as a source but as well as a sink for carbon. So indeed, today the world is getting a better understanding, and this not just as a simple acknowledgement that we already digested decades ago, but on just how important forests are in the global warming. A new research found that the world's forest stores about twice as much carbon dioxide as they emitted between 2001 and 2019. Here in a map, or in other words, forests provide a carbon sink that absorbs net 7.6 billion metric tons of CO2 per year, which in comparison, to give you an idea, is 1.5 times more carbon than the United States emits annually. Here you can see some examples, some more specific details with a concerning region where we actually, Archetype Group is very active, and which is obviously active in the construction industry for the past years. You see that the Amazon is today a sink with a net flux of 10 metric billion CO2 per year. You have also the Congo River Basin, which also today a sink, but unfortunately, Southeast Asia today represent a source of 0.49 metric tons of CO2 per year. So how to find a virtuous circle with this forest topic? So, for example, this sketch here is showing an example in Canada of the benefit of sustainable forest management. So let's, as Eleni talked about tools with the edge, so we should talk about tools for the future. So we are not just here talking about planting for planting, but more for planting better, I would say. Indeed, economical, sensible wood production is not only based on square cubic meters. Price, cost, interest rates, and forest owners' objectives must be noticed. So there is different way to deal with this. So shall we be promoting the forest growth usage in better selections, better choice of essence of wood, for which purpose, for the which target? So one of the examples, shall we be focusing in fir tree, which takes 15 years to grow and used mostly for wooden pallet? Or should we be focusing on wood burl in North America, which is very popular and pursue for the furniture supply and other decorative elements? Or a teak trees that take 70 years to develop, and but to develop these trees, on the other hand, you need to create a primary forest, then a secondary, in order to generate a climate and an environment sustainable for the growth of these teak trees. So there were some I would say some tries done in the past, for example in South America, where wood essence was planted originally from a teak essence. But unfortunately, this was abandoned because those trees never really reached the mechanical properties that they were needed for. So they could not answer to the demand. So at the end, it was abandoned and all these forests were cut and never grown again. So there should be probably some research to be financed on this side, on how to find the right essence for the right purpose, so create the virtuous circle. So to support this optimized selection, there is one important topic here, which should be the reevaluation of prices and actually the basic value of timber. Indeed, today we're facing some issue, for example, with embargoes, sanctions, for example, a lot of countries where those forests are developed and are predominant. And this creates a huge problem as, for example, prices are really sinking down up to 3 to 4 times the real value. There is a huge loss of interest from the local population. And this pushes them to have an inadequate use of trees and timber for everyday life, and therefore causing savage cuttings in those forests. Without talking about the unscrupulous trading, into black markets and etc. Therefore, it shows a loss in motivation on maintaining and replanting those sources of oxygen. So the result is that local people decide, and they say, let's cut and make paddy fields, as it generates for them obvious more revenue, more profit. So in order again to promote a better growth, an increase replantation of timber, let's talk about some tools. So we are facing today, unfortunately, a problem which is using tools from the past. And I'm not talking here only about modern machines, which today in mass production, such as this equipment, can use up to 15 liters of diesel for a few minutes of use. And this in comparison with more ancestral methods that actually are in some time more sustainable methods in difficult terrain, more appropriate for the local population. Therefore, I wanted to quickly introduce a modern tool that doesn't seem to be and obviously immediately linked to forest growth and mass timber. We are facing today problems of heavy systems dragging most of forest development. It exists, nevertheless, some new financial tools that would help to eliminate so many intermediates, so many bureaucracy, which today are indirectly increasing carbon footprint. How you would say, well, when you have a big organization, I know it's a sensitive topic here, but when you have big organization and all the checking bodies involved and all the people on the terrain, which actually COVID allowed and showed that this management could be done remotely. Today, in the past, or even still today, those organizations need offices, need to build offices, need to bring people on each country, which associate issues and consequences like transportation, the flights, the cars, bringing all their goods, their families, etc. But this, unfortunately, also create a huge carbon footprint on this type of management. So to regain trust and confidence in forest management tools, which are old at this stage, there is, I would say, a newly trained tool that's called blockchain, as you may have heard. This is a simple tool that is becoming trendy, and it allows a lot of saving that can be reinvested and reused directly into the system. And one of the good example is a blockchain named Cardano, for those who don't know. And Cardano so far have allowed to fund privately 47% of their target, which is a 1 million tree plantation. So with this tool, each one of us can actually buy directly the plantation of up to one tree itself. And this allows each people who plant the tree to be directly paid each tree that you finance has its own number, its own geolocalization type. So much less carbon is used, obviously, with this system. No need of trouble, no need of numerous intermediate, etc. You have also immediate and simultaneous verification of all the actors in this growing and planting process in order to make sure that a real reforestation is done. And Very3, which is one of the control organization, allows you to avoid all the risk raised by this system. And now, to relate a bit this blockchain to our industry, we have recently had a very interesting workshop held by Michael. Can you maybe next slide? Michael Wong from Marriott International Hotels, who explained to us that blockchain was already one of the focus of Marriott, and not only for its financial aspects. Indeed, they are exploring different options on how to use these tools, and this also in design, in project management, in property development, helping procurement, or verification on site, or sharing information, or directly paying the suppliers. So this is a trendy, I would say, tool that would definitely allow a growth of promotion and interest in the area of forest growth. So how to change this vicious circle of the forest, the dissipation of forest, into a virtuous circle? So how we designer can influence it? How can we push for an increase or for a better use of timber in the construction or in our design? So we can, for example, as today, communicate on the value and advantage of using timber. So what was once sounding like a green construction dream is now an increasing trend. And we start to see timber buildings growing and rising across not only North America, but Europe and Australia. So there is, for example, an initiative made a few years ago by US government, which with the US tall wood building price competition, which was offering a price of $2 million as a context to encourage more wood-based multi-story. So it was one of the beginning of the interest into this technology and use of timber. So of course, governments and construction companies still need to get used to this idea, and especially building codes need to change. So far, the most widely used codes limit wooden construction up to 20 story. So let's go back to mass timber and see how was it developed. So-called mass timber is derived from old techniques of post and beam construction. This uses also advanced technologies such as cross-laminated timbers, as you may have heard of, called CLT, or laminated vinyl lumber, LVL. These features layers of wood bonded with adhesives and produced as either beams or panels. So structural wood products like CLT have a number of advantages in tall wooden building construction. They are lighter than conventional materials, but also require less energy to make than either steel or concrete. And those produce lower emissions and can store carbon. Their relative lightness also makes it possible to assemble floor and wall section off site and ship them directly to the building site, significantly reducing the amount of building time as well and required. So if today, if I focus to and start to give some study case, we will focus more into the CLT technique. So this was invented in Austria in the mid 90s, and this type of engineering timber is now facing a huge success, and especially in Europe. CLT panels consist of not less than 3 cross-bonded layers of timber, typically ranging in thickness, which may be a bit differing, but the timber is strength graded to the needed standard, often a British standard, and glued together in the press. This which applies pressure over the entire surface of the panel. CLT panels have an odd number of layers, usually is 3, 5, 7, or 9, and are arranged symmetrically around the middle layer, with adjacent layers having their grain direction at right angle to one another. Here in this next slide, you can see, for example, in comparison, the different span that the cross-laminate CLT techniques can offer into the construction in this study made by the Structural Timber Association in the UK. So you can see that you can reach a span up to 8 meters, which is usually a good standard for some residential project. Then on this document, we also can notice all the usage of CLT on different part and area of the building. So you have the roof, the ceilings, you can see multi-story platform frame construction using CLT, but also some here typical details that you will see also later on another project on wall floor junction. So there is definitely a huge development on those construction details using CLT element. Also, CLT can offer good thermal insulation performance and good sound insulation properties, which are nowadays one of the musts in, for example, hospitality, but also residential in general. CLT can be used to contribute actually toward the overall U value of the building, of any building. So this is due to this relatively low thermal conductivity. So can you switch? Yes, sir. So the key of the success is especially also into his modular prefabricated structures and the important flexibility of use. Here, another but non-exhaustive list showing different use of CLT. So you have wall element, floor, ceiling, roof, and others such as stairs or even furniture, obviously. But so far, CLT has been used mainly for low-rise, I would say, commercial mixed-use buildings. But recently, as the technology, its know-how are improving, architects and developers are beginning to propose buildings made in CLT with increasing number of floors. So even though high-rise buildings are still controversial as a use with CLT, knowing that the first problem is fire regulation in many countries, this is now a trend that is changing. And the second problem being, of course, also the structural scheme, which poses sometimes problems as those wall panels and slabs are usually arranged in a type of house of cards-like configuration. But again, there is more and more solutions today which are bringing options to enabling creativity and rising the number of floors. So here I'm going to to show you a few example build, for example. So this is the Treat Tower in Bergen, Norway, which was completed in 2015 and designed by Artec Office. Treat, meaning the tree in Norwegian, is a 49.4 meter high, so approximately 50 meter high apartment tower. And until 2018, this was the world's highest residential building made in timber. So it's composed of 18 stories and of 62 dwelling units. So the building is entirely made in CLT, with its main structure consisting of glulam truss work, while CLT were used for elevator shafts, staircase, internal walls, and balconies. Then additionally, a number of concrete floors were installed on the 5 first floors to increase the building weight and improve its structural dynamic behavior. Now, more recently, we have another project still in Norway, which seems that Norway getting a lead in these construction methods. So you have the Mjøstarnet in Brumunddal city, and this was completed in 2019. This is an 85-meter tower, and it is so far the world's tallest timber building built. It's the design of Vol architecture, and it's composed of hotels, 33 apartments, restaurants, and offices. Here, the structure again is made of glulam trusses, columns, and bill, while the CLT here was used for stiffening elements, and again to build the elevator shaft and the staircase. And in order to fulfill, local regulation in terms of fire, the facade was cladded with special fireproof pine timber boards, which gave us some answer into the local regulation. So now a last study case. This is in Canada, in Quebec City, with the project named Origin. This project, designed by Yvan Blouin Architects, was actually completed. The construction was actually completed in only 4 months. So CLT was used in composing exterior walls, stair, elevator, shaft walls, on non-load-bearing interior walls, floors, and roofs as well. So in this illustration, we can see that structural elements here were composed of 7 main shear walls made of CLT. So you have the 3 walls in the lobby in blue. I cannot show my mouse here. Well, so you have also the back wall in the emergency staircase and elevator shaft. Yeah, thank you. Oops, no. Sorry about that. I mean, if we do it together. The mouse not working here. Okay, no, neither. No, I cannot see. Never mind. No. So there was also the back wall in the emergency exit staircase and elevator shafts. You can see also the central portion of the north wall, and the central both portion in east and west walls. The floors here shown partially in brown acted like a diaphragm to transfer lateral loads toward the shear walls. And the gravity load resisting system was made of CLT load bearing walls, which you can see in purple there. And finally, 2 glulam posts and beam axes here you can in yellow and green were completing the main structure of this building. Finally, here, in terms of foundation, we can see that shear walls were connected, timber shear walls were connected with steel plates to the foundation. And this was a picture taken during the testing time of the design. Then firefighting was as well drastically examined. So if proper fireproofing materials and sprinklers are early incorporated into this design, so in the event of fire, the design minimizes dangers and allow the inhabitant to escape, obviously, and the fire to be brought under control. Here, quickly, several details, I would say, tailor-made by Yvan Blouin, the architects, which shows all the creativity on how floors and walls could be combined with CLT usage. And here a picture of the building under construction showing this prefabrication method. So prefabrication also means that building structures can be designed to maximize energy efficiency, since individual component again can be built precisely into a factory, minimizing errors, of course, but also ensuring that measurements are exact. And this, as you can imagine, implicates less transportation, so less indirect carbon production, but not only for the materials and the prefabricated element, but also in the production and for the actors of the construction themselves, being only present for months. So let's build more, better, wisely, I would say greener, with mass timber, and mass timber can support this mission. Tall wooden buildings store carbon, preventing it from entering into the atmosphere. So in contrast, building made of steel, unfortunately, generate large amount of carbon emission per ton of material produced so far. So latest news showing that the crown of the tallest wood buildings will be hard to keep, as we heard that there was already a proposal in Japan, in Tokyo, with a 350-meter tall and 70-story building high under design for the title of the tallest timber building. But I will let our friend and colleagues from the CTBUH follow up closely this project and give us more updates. So thank you very much for your time today. Thank you again to all our speakers. We have a short, I guess, Q&A session. If we still have people not exhausted by this long presentation and all interesting yes, so anybody?
So I think there's a question about some of the things that I talked about around existing buildings. So there's a question about whether we're talking about embodied carbon or operational whole life carbon with EDGE. So EDGE right now only accounts for operational zero carbon, and when we're talking about existing buildings, it's always around the operational component. IFC is working on changing the embodied energy and materials into an embodied carbon calculator. So whole life cycle carbon, zero carbon will be available in EDGE, hopefully next year. I think timelines are always, it's always a question when you're developing something new. But of course, the entire industry is moving towards whole life cycle carbon. But for EDGE in particular, it's taking the architecture 2030 definition of making the building as efficient as possible first, before then looking at the operational energy and looking at a combination of on-site, off-site renewable energy, and then finally offsets as the last resort to be able to get to operationally zero carbon. So building has to be at minimum 40% more energy efficient compared to the baseline first, before touching any of the other areas to get to zero carbon. Hopefully that answered the question.
Sorry, again, my microphone. Thank you, Eleni, for this answer. So while maybe some of our listeners are maybe thinking of a question, I wanted just to re-insist on this great opportunity that EDGE can provide as an alternative to other green certification, and how this was created actually to probably simplify the process of green certification, that it's of a great benefit for not, of course, the environment, but the developers. And recently, we have seen a rising interest, especially in Africa, where some of our clients, since the beginning, are asking to incorporate at the even master planning stage the condition of how to implement the EDGE certification into their project. Well, I don't see much more question. So anyway, thank you. I wanted to thank you, Antoine, sorry, for your presentation. To men as well. You are probably now in a very cold situation in Ulaanbaatar. What is the temperature outside now?
-20.
Ah, okay.
Not that bad.
Yes, I heard of worse situation. So thank you also, Eleni. It was a pleasure to have you on board today. So still no question arising. So well, thank you everyone for participating to this webinar. I hope it has raised the interest on the topic of carbon footprint, and especially in the EDGE certification. So please don't hesitate to contact Eleni for having more information on this label, but as well our team, if you want to combine effort in some of development, or anyway, if you have any question in this, how to use the tool. Again, this is a fantastic web-based platform tool that you can use and to say, simulate your project. So thank you very much. Hope to meet you, Eleni, in person sooner or later, if when the traveling is getting easier. And that's it for our webinar today. Thank you very much.
Thank you very much.
Thank you all.
Okay, thank you very much. Bye-bye.
Bye.